So, members, back in our chemistry, we are looking at calculations involving molar gas what? Volume. You know, molar gas volume, that is the volume occupied by one mole of what? One mole of a gas. Now, molar gas volume, we can see that we have two. We have one when we are taking the gas to be at standard temperature and pressure, and another one when you are taking the gas to be at room temperature. So molar gas volume at STP, if you are considering the one in decimeters, we have 22.4 decimeters what? Cubed. Then if we convert that one to cubic centimeters, then we shall get now 22 thousands, then 400, or what we can say 22400 cubic what? Cubic centimeters. Then if you are taking that one at RTP, we have 24 decimeters. Remember, RTP means room temperature. Then STP means standard temperature and pressure. I'm saying STP, standard temperature and pressure, RTP, room temperature and pressure. Then RTP volume, we are seeing 24 decimeters, which can be 24,000 cubic what? Centimeters. Now we want to see how we can use this one to find number of moles and other volumes and masses of different chemical substances. So one example that can paint a good picture, members, is this example. They are saying calculate the volume of a gas that would be evolved at STP when 42.0 grams of sodium hydrogen carbonate are heated strongly until no further change. But they are saying hydrogen, as it appears in the periodic table, is equivalent to 1, carbon 12, oxygen 16, sodium 23, and at the same time, they are saying 1 mole of a gas occupies 22.4 decimeters cubed at STP. Now, solution to the question, the beginning point, we have to write the equation. That is the beginning approach. Our approach will be, you write the equation of the reaction. After writing the equation of the reaction, then we have to find what we call molar mass of sodium hydrogen what? Carbonate. Then in our approach still, number 3, we have to find what we are calling moles of sodium hydrogen carbonate. Then from there, we have to use now molar ratio. Use molar ratio. How to use molar ratio to find moles. Find moles of carbon what? Carbon dioxide gas, which has been what? Produced. Then finally, we shall convert moles of carbon dioxide gas into what we are calling volume now. So let us begin by writing our equation. We can say that sodium hydrogen carbonate, this is a solid now, is being heated. You can use the arrow there. We are heating it, heated. Then to produce what we are calling sodium carbonate, plus carbon dioxide, don't forget that, then plus water. So when you're writing your equation, try to mind about the symbols of the elements as well as point of balancing the equation. So now we can balance the equation, you can see by putting a 2 here. When you put a 2 there, we will see our equation is becoming what? Balanced now. Now after writing a balanced equation, we are saying we find moles, we find the molar mass of sodium hydrogen carbonate. Now here we shall say molar mass of sodium hydrogen carbonate, Now it's going to be equivalent. We go back to relative atomic masses as they are being reflected here in the periodic what? The periodic what? Table. So we are having now sodium is 23, is appearing how many times? Once. Is appearing once there. Let me try to. So we are saying, we are going to say 23 times 1. Why? It is appearing once here. Then plus the hydrogen being represented by 1. So we have 1 times 1 because it's appearing once. Then plus 12 times 1 is 12 as is appearing here, then is appearing once. Then plus 16 times how many? 3. Now this one we are going to get a total now of 84. This is 84 grams. That is molar mass. Now after finding our molar mass, we say this third step is to find moles. So you're going to find the number of moles. So we say number of moles now equivalent to the mass of sodium hydrogen carbonate, divided by the molar mass. So our mass, remember, was 42.0 divided by the molar mass which I have got, which is 84. And this one we are getting our moles as 0.5 moles. These are moles of sodium hydrogen what? Sodium hydrogen carbonate. Don't forget that. Now, after getting our moles of sodium hydrogen carbonate members, then we are going to use the mole ratio. Now we are going to come back to our equation here, which we wrote. Look at our equation here. Our mole ratio we have now. Remember, we are looking at how much carbon dioxide produced by sodium hydrogen carbonate. That is 1 is 2 to what? To 1. There is a 2 in front here, and there is a hidden 1 in front here, in front of carbon dioxide. Therefore, we can say our mole ratio now is going to be 2 to 1. This implies that 2 moles of sodium hydrogen carbonate. So we are saying 2 moles of sodium hydrogen carbonate, produce 1 mole of carbon dioxide gas now. So what about the other moles which you have calculated of sodium hydrogen carbonate? Those moles of sodium hydrogen carbonate produce, then we are going to do what? To cross multiply. That is 0.5, this one here, times the 1 there, divided by this 2 this side. So we are getting this one times this one divided by that one. And now here we are going to be having what we are saying, 0.225. And you get your calculator there, also you compute, and you see what you are getting. That is 0.25. Now after getting these moles, then we are going to convert them into the volume as we said here. So we are going to say now, we know properly that moles of a gas are exactly equal to the volume of the gas. Now this time volume of carbon dioxide, and this one are moles of carbon dioxide now, which you have got, divided by what you are calling molar gas what? Molar gas volume. Molar gas volume, which you have already in the question. So here we are going to get, now we are going to make our volume the subject. Therefore our volume of the gas, volume of carbon dioxide, now we are making this one the subject, is what we want. It's going to be equivalent to the moles which you have calculated already of carbon dioxide, moles of carbon dioxide, then times the molar gas what? Molar gas volume. Molar gas what? Volume. So here we are going to obtain what we are calling 0.25, our moles we have calculated of carbon dioxide times molar gas volume, which is 22.4 decimeters cubed. Don't forget that. And here now our final answer, which you are getting when you get your calculator, that is 5.6 decimeters what? Decimeters cubed. Now if this one is hard for you, you can alternatively say, you come back to your equation as you wrote the equation. Remember our equation was sodium hydrogen carbonate decomposed. This is an alternative now. Sodium is decomposing to form sodium carbonate plus carbon dioxide, then plus what? Plus water. This is our gas, this is our solid, and this is our solid. I added 2 here. Now, already we got the molar mass of sodium ionic carbonate as 84. So we can put here 84 for sodium ionic carbonate. But it is a 2 here. So we multiply by a 2 there. These are grams. They are producing what? Produces this one, but this one is going to be represented by the molar gas volume. 1 mole. Produces 1 mole of carbon dioxide. But remember, 1 mole is equivalent to 22.4 decimeters. As we said, it's the volume occupied by 1 mole of the gas. Therefore, it produces 1, which is in front here, times this value, which is produces 22.4 decimeters cubed of carbon dioxide gas. Then, if it is like that, then we say, what about the grams given the question? What about the 42.0 grams of carbon dioxide? 42.0 grams of sodium hydrogen what? Carbonate. This one produces what? Produces, we are going to cross multiply. That is 42.0 times 22.4 divided by, I'm going to divide by 2 times 84. And now the value which you are going to put in here will be 5.6 decimeters what? Cubed. So that is another alternative which you can use to. So members, our second example, they are saying 15.6 grams of potassium, that is potassium metal. Now the grams were burnt in excess oxygen to form potassium oxide. They are saying calculate the volume at standard temperature and pressure needed for complete combustion. Now, in this question, still as we did the first one, we begin by writing our equation. So in our solution here, a student must write the equation. That is potassium plus our oxygen gas. Remember, potassium is a solid. And here, we are going to obtain what we are calling potassium oxide solid. Then here we can balance the equation by putting a 4 there and putting a 2 there. Our equation is going to be balanced at that what? At that point. After balancing the equation, then we say the second step after writing the equation. Mind about that K properly. The K should be clearly what? Written when you are writing. Don't write as I've been writing here. Now from there, we get now the molar mass. Molar mass now, this time, because it is only one element, potassium, I can even call it relative atomic what? Relative atomic mass, because it's only potassium. And this one is 39 potassium. Then after getting that, the second point is to find moles of potassium. Moles of potassium. This one is going to be equivalent to the mass of potassium divided by the now relative atomic what? Mass. It will be molar mass if the elements have been made by this only one element. So there we get now our 15.6 grams divided by the 30 what? The 39. Then after dividing now, when you get your calculator, there we're going to obtain what we are saying 0.4 moles of what? Of potassium. Remember, the question is telling us to find oxygen which reacted. Now here we can find our moles of oxygen. That is by applying mole what? Mole ratio. From our equation here we see it is 4. You have this 4 here, and then it is a hidden 1 here. Therefore, our mole ratio here is going to be 4 to what? To 1. This means now 4 moles of potassium. I'm representing with this symbol. React with 1 mole 1 mole of oxygen now, gas. Now what about the other moles which you have got? The 0.4 moles of the same of potassium now react with, we are going to cross multiply the 0.4, this one here, times the one here, divided by the 4. And now we shall get our value as 0.1 moles of now, of our oxygen now. This is our oxygen. So remember we said volume of the gas from moles are equivalent the volume of now oxygen, and these ones are moles of what? Oxygen. Now divided by what we are calling molar gas volume, which is given the question they have given us now 22.4. So here we are going to divide by molar gas volume, which is 22.4 decimeters. Now we are going to make now this one the subject. We are making this one the subject, and our volume is going to be volume of now oxygen, which reacted with potassium, is equivalent to the moles of oxygen times molar gas volume, which is 22.4. Now it means you are going to put in 0.1 times 22.4, and our final answer is going to be 2.24 now decimeters cubed. Alternatively, as we said there, you can only bring now the other mass of potassium, which was 39. Remember, from the equation you add potassium plus oxygen, don't forget that, to form potassium oxide, like that. Here we add the 4, like that, and here you add the 2. Now we are considering this and this, but this one is 39 potassium. There is this 4, you multiply by that 4 in the front here. Then these grams reacts with now the molar gas volume, because 1 mole of oxygen is occupying 22.4 decimeters. Then what about the grams given the question? What about the 15.6 grams reacts with? Then we are going to cross multiply. That is 15.6 times 22.4 divided by 4 times 30 what? Times 39. And now our overall value is going to become 224 decimeters cubed. Members, after grasping the other content I've been telling you, we are going to try these questions. These are try questions acting as our assignment. They are saying question 1, calculate the volume of carbon dioxide measured at STP. Standard temperature and pressure is what we are calling STP. So they are saying measured at STP, that will be produced when 15.9 grams of anhydrous sodium carbonate are reacted with excess dilute hydrochloric acid. They are saying 1 mole of a gas occupies 22.4 decimeters at standard temperature and pressure. That is molar gas volume. Then they are saying carbon is equivalent to 12, oxygen 16, sodium 23. Then question 2, they are saying calculate the mass of zinc that will be required to produce 4,480 cubic centimeters of hydrogen gas at standard temperature and pressure. They have given you the equation as you are seeing, zinc plus sulfuric acid from zinc sulfate plus hydrogen gas. Zinc, this is the relative atomic mass, and then of course they have given MGV or molar gas volume, which is 22.4 decimeters cubed at STP. And this is our answer which we want. So the way where you are seeing a star, that is our answer, it is 13. This is what we are going to prove. Then lastly, question 3, they are saying 0.1 molar of hydrochloric acid were added to sodium carbonate solution. Then they are saying you calculate the volume of carbon dioxide that will be evolved at room temperature. That is RTP. Then they are specifying that 1 mole of the gas occupies 24 decimeters at room temperature. And our answer, which we want, is 1.2. What we are going to prove. So try, then you see whether you have got the concept.